Okay, let's get into chapter 8 here, confidence intervals. This is going to be kind of our introduction into tests. So basically, we're going to draw up an area that we think we're pretty confident that the data should end up in there. And we're going to get really comfortable drawing these confidence intervals. And as long as the data ends up in our intervals, we're going to be pretty comfortable with it. But if our data starts falling outside of there, we're going to question whether our data is real. That is the entire purpose of the tests that we'll learn in the next chapter, and that's kind of the easiest way to summarize this whole thing. So we're going to start with building our confidence intervals. Let's get through some of this. So this is kind of what I just said. So we're going to take estimates from our sample data, and we're going to find a point estimate. So our point estimate here is going to be our sample mean and the sample standard deviation S. And the sample mean X is the point estimate. It estimates our population mean. It isn't the population mean, but it's an estimate of it. And the sample deviation S is the point estimate for the population. So once again, we're going to take both of these, and we've talked about this before. Each of these are statistics. They're estimates of the population, estimates of what we think the population is. So let's skip these two for right now. And then we're going to take that estimate and we're going to say, well, let's go a standard deviation above and a standard deviation below. So here we have one standard deviation above and one below. So I think maybe it's easiest to visualize this first. So this is taking these confidence intervals, and you see we have 0 here. So this is all in terms of the same unit. Confidence intervals do not have to be, so you could put this, that's what this formula here is doing. Kind of taking this, and instead of -3 standard deviations down here, it would actually be what 3 standard deviations away from our mean is in that unit. So this is kind of putting it all into our normal standard deviation units. And I hope that that helps, because you can see where this is drawn from our empirical rule. So we've talked about the empirical rule. It was on the last quiz pretty extensively. And we know if we're a standard deviation above and below our mean, we're going to expect 68% of the data to fall in there. That's a confidence interval. We're confident that 68% of the data is going to end up in this section. We're confident that 95% is going to end up in this section. And the same for 99.7. So within 3 standard deviations, we're confident that almost all of the data is going to be here. What that also tells you is if you get data out here and our confidence interval lies in here, maybe we have some red flags and maybe this isn't true. Our confidence interval is then determined by this, and I kind of told you this is just putting that into practice. You'll get some work on this with the homework. And I'm more worried about just kind of describing how we make the confidence interval kind of as an overarching view. So basically, we're going to take our point estimate. Now remember, our point estimate here will be a mean, not 0. So don't get too hung up on this. Instead, we're going to have an actual mean value there. And we're going to have our margin of error, which is the standard deviation with the in the correct units. And we're going to put that at a certain level. So we want 95%, which is going to be a certain number of standard deviations, which we can find here. It's 2 standard deviations. And then we'll put that 2 standard deviations into the correct margin of error. So put it into the same units that we're asking. And then we'll just say 2 standard deviations below our point estimate and 2 standard deviations above our point estimate. And we know that, that's where we expect the data to fall.